Hello everyone and welcome to the second Atlas webinar regarding the open call that is running right now. And as you know, we decided to hold this 4 sessions with our experts to answer all your questions and to walk you through all the peculiarities of our project and of our open call. So I'm very pleased to introduce to you my colleagues today, Marco Caballero. He's one of the Atlas partners representing AgriCircle company. And Matik, he's a winner of last year's open call. He won the open call with a solution called eVineyard. And he will share today with you his insights. I think it's the most valuable ones. Right, and we are waiting that our coordinator, Stefan Rehling, is joining us later on. Yeah, so we are all ready for your questions, straightforward. You all know where to find the questions area. Right, and I would like to start our webinar today with Matik's introduction and his insights about our open call last year and his experience. Please go on.
Yeah, thank you, Tamara. So my name is Matik from Elmibit. We're a small, basically SME from Slovenia. We are building software products called eVineyard and eOrchard, which are basically vineyard and orchard management software systems. And yeah, we applied last year to Atlas with a solution inside eVineyard that is related to asset tracking. So there was like a group of topics to which we could apply, which I believe is similar this time. And we believe to have an interesting solution in development for the topic of asset tracking, where we are basically increasing the precision of all the tracking of the activities of the assets of what is being done in the vineyard to a higher level of precision. So if we used to work on the block level initially, then we are moving within our project that we are working on inside Atlas to the level of basically vine level precision. So eventually we are going to generate some very precise maps of the vineyards. And then Atlas is basically all about connecting different solutions in as seamless and standard way as possible. And this is what was interesting for us. So as we are producing some interesting data that other perhaps farm management information systems or autonomous machinery systems or any other systems can use, how can we expose this data and get connected with other solutions and systems? And this is how we started looking into Atlas. Like as a company, we're working for quite a few years already, and always with a bit bigger customers, we always had to integrate with one solution here, one solution there. There is always something that they use on farm. And from that point of view, Atlas is an interesting project as it tries to somehow standardize and bring those things together in a ordered, standardized fashion where things can also work in a plug and play way. This is at least how we see it. We saw it initially, and this is what sparks our interest quite a lot. This is how we applied. Managed to become one of the selected companies, and now we're happily working on the solution as well as on the interconnection. So if I can give a few recommendations also for the application, how to prepare it, I would say that if you have something that you are working on where interconnectivity with the other systems can be of interest, and of course if you are working on something, it has to be interesting for somebody, for some end user. Then that's definitely like the ideal situation, because yeah, through the open call of Atlas, you will be able to somehow get the solution further in its development, and at the same time connect it with other systems, which can be either from the other open call winners, as well as from the other partners in Atlas. And it's so far it's been a great experience. Like, there is quite a lot of different actors involved, from those who are dealing with standardization to those who are providing some solutions or piloting some solutions and so on. So it's a really interesting like ecosystem to fall into, and then discover what's possible and work on that. But yeah, if I have to say what would be the recommendation for writing up a good application, is ideally you want to propose some good solution that is really practically useful for somebody, and that also can connect with some other solutions. That's what we try to then also convey in the application that we wrote. And yeah, finally it proved as successful. So moving on to implementation process, one part is definitely what we know and what we're doing. The other part is related to Atlas, to the technical infrastructure, which is also being developed by the other partners of Atlas. In the meantime, I believe Stefan in the later stage will explain that a little bit more in depth. And yeah, I think that would kind of sum it up. But yeah, I'm very happy to take also any questions, like respond to them about how to, like, about our experience and how we were successful in this case.
Thank you very much, Matik. Yeah, and I'm referring to our audience. Please send your questions. We will all answer all your questions during this hour. So I don't see any of them yet, but Matik, I have one question. Is there anything that you wish you knew before you applied for the call, or before you started the implementation?
Yeah, well, perhaps a bit more information about the pilot locations, or the ability to contact the pilot locations could be an interesting thing. So we spoke with the relevant like pilot site, for example, in our case, after the application process. But initially, if we would speak maybe earlier, that could perhaps be useful to also kind of put it ahead in the application process, potentially.
Yeah, no, that's true. And at the end, which pilot site you are using now to implement your solution?
So we have at the moment our own pilot site that we brought into the project. However, we have discussed also with the pilot site in Romania, like now as we are in the project. So if we discussed maybe earlier, we would slightly change the application probably, to make it more suitable also for their site, like perhaps. But
Yeah, I understand. The reason was that we started the first open call quite early at the beginning of the project, and so we are operating more or less as a startup ourselves. And yeah, the information is changing, and now the participants of the second open call, they are in a better position in terms of they have more information now, because our network is developed as well. Thank you very much, Matik. If there are any questions later on, I will let you know. Please stay with us. So I would ask Marco to step in and to explain a little bit more about what Atlas is and what Atlas isn't, probably. And yeah, please go on.
All right. Yes. So Apologies, I don't have any nice material to to support this description. This is usually taken care of by Stefan, but nevertheless, I'm one of the architects of Atlas, so I have a good grip of that. I hope I'll be able to convey the most important aspects to you. So the key feature of Atlas is, as was mentioned, is about interoperability of agricultural systems. We recognize that out there are a number of systems, and farmers may often use more than one system to fulfill their needs in different areas of agriculture. And that often involves duplication of data. I mean, if you think in the agricultural side, I mean, a very basic examples would be field boundaries. I mean, pretty much every system that would deal with fertilization, things like this, needs to have information about boundaries, and farmers end up very often replicating that information in different systems simply because they need it. And so it's hard to maintain, to keep up to date, and so on and so forth. We also recognize in Atlas, or at least what we want to promote, is the ability for farmers at the end of the day, or let's say for IT expert, to assemble the best solution that's suitable for a farmer. We don't believe in, let's say, in the generalistic and bloated do-it-all one-stop shop solutions. I mean, these solutions end up being at most mediocre because they're average. They try to cover so much ground that they end up being very average on all of those areas. What we try to promote is the ability, through the interoperability mechanisms that we present, to be able to construct the system that will best satisfy the needs of a farmer. Different farmers will have different requirements. In some cases, they may want to have access to very sophisticated and maybe expensive services in a particular area that's important to them, while having, let's say, more average run-of-the-mill solutions for other things which are not as critical for them. And so fundamentally, what Atlas is bringing to the table is a way of looking at different activities in the agricultural world at large as building blocks that can talk to each other. So in order to support that, so we call this, so let's think again, I'm familiar with that example. Let's think about a fertilization service. You could have many different ways of doing a fertilization service. The simplest one would just say, spread a tot amount of kilos per year per hectare, and that's it. That's a fertilization service, and that's actually how many farmers work today with fertilization. Other services might use, for instance, remote sensing, satellite information, in order to provide precision farming information so that you can optimize the requirements on a specific area. What we want with Atlas is to say we have a category of service, which is the fertilization service. We abstract that, and you'll hear that going on with the term service template. It means it's something that has a well-defined API. So everyone who will build a fertilization service will have to implement precisely the API that's generically defined. And this allows basically the farmer to mix and match, to say, hey, I prefer this service over that one because it's simply maybe more efficient in my part of the world, or more efficient for the type of crop I'm focusing on, and so on and so forth. But so a very key element is to build those Lego pieces. So as software developers, particularly in your case as open call members, you might end up building services which implement a particular service template, and that's the key basically to interoperability. Since again, every service implementing the same template, it is basically interchangeable. I mean, it doesn't do exactly it doesn't do the things in the same way, but it provides the same end result and has the same APIs. So in order to make this world work, there We also try in Atlas to minimize the number of central components, but we need to have a couple. So one central, oh, here's Stefan. Stefan, do you want to take over from here? I don't know how much you heard, but you have some good slides to support the intro of Atlas.
I just joined in. Apologies for being late. I was completely
no problem, Stefan, no
by
problem.
another
Marco,
incident. Sorry for this.
No problem. We understand. I will make you presenter quickly. I've tried to improvise with the website, but yeah, I don't know if you saw the website.
Yeah, so
but
I give a 3 minutes intro. You can do your normal presentation from here. I think
Perfect. So apologies for this. Usually it doesn't happen. Sometimes it does. I hope
okay, so we understand there was a reason for that, so that's fine. Right, so you are presenter, Stefan, so you can go ahead.
Perfect. Yes, okay, just a second. I share the screen. Do you see the screen now? Good, so good afternoon. Apologies for the delay from my side. My name is Stefan Rilling. I'm a researcher at Fraunhofer Institute for Intelligent Analysis and Information Systems. And I'm the coordinator of the Atlas project, which you have for sure been already introduced to. And the goal of today's webinar is to present you a little bit more of the technical details of the architecture underlying the Atlas Interoperability Network. This is what we call the Atlas Reference Architecture, and which will be more or less the foundation of the integration work, which would then be done from the side of the open call participants, or at least from the open call winners. So I think that was probably part of Malku's introduction already. So and for sure this is not new to you. Farming is complex, and there is a lot of processes involved, a lot of things to manage, and in modern architecture, at least in a large-scale agriculture operations, there are a lot of software tools already in use. So here is an example from one of our consortium partners, one farm, several fields distributed over a quite large area, and 7 different software systems in use. And all of these software systems somehow have to interchange data with each other in order to give a contribution to the processes, to the agricultural processes, and to be useful for these. So what you also probably know is that you have usually you have machines from multiple vendors, and these also have to somehow work together. There are already standards for this on a machinery level, so that you can plug in your implement to the tractor and it somehow works. But also there is on the data side, there are still open problems to be solved. So, and this is where Atlas comes in. So we have this heterogeneous landscape of technology, so to say. We have sensors, we have machines, we have data processing services. We also have more modern pieces of equipment like robots, and everything needs to play somehow together, which we call interoperability between these systems. And one key capability of being interoperable is a data exchange between all these entities needs to be possible. And what we are doing in Atlas is exactly defining a system architecture to solve this interoperability problem. And this architecture is based on open standards, and it's extensible. And yeah, we define basically the interfaces and the data formats for data exchange between these systems. And what we have is a high-level reference architecture, which has already been in some parts implemented. So there is already something there which works and which could be used. But what we did in more or less the first year of Atlas is to specify the basic interoperability building blocks. And what we have here is two concepts which complement each other. So we have I would say the classical exchange of data between data platforms. Consider, for example, you have your farm management information system, and you connect that with the portal where you have your agricultural machine, or with a portal where you can get satellite data. So this is this part of data exchange of interoperability. But we also came to the conclusion that we need onboard or on-site computing and processing capabilities, so to say, at the edge of the network. And we are also define architectural elements to solve that problem, and to connect also the edge of the network to the data platforms. And what we have in mind is a network of services to solve the interoperability problem that has already been set. The idea is to have here a minimum of central components, and around these components a network of decentralized services. And to operate such a network, you basically need an entity which serves as, can I imagine it as a phone book. You need to do a service discovery. You need to know what is there and how to connect to it. And these two central elements we have foreseen here is the service registry, which is a trusted directory of participants, and where the services they offer are listed. And we have the equipment center, which offers a unified view of the farmer's equipment, so robots, tractors, all kinds of sensor networks, and which enables the communication between services and the so-called apps. So apps, that's something you probably know from your smartphone. So we also define a element which serves as an edge computing platform, which can be then run at the edge of the network, for example, on a machine or in a barn, and we call that element App Engine. So two central components, service registry and equipment center, and multiple app engines available. Sorry. The basic building or the basic connection element to exchange data, these are the services. And services are offered by participants. Participants are legal entities, companies, which providing software system. For example, a farm management information system, or a machinery platform. And these participants are registered in the service registry. And these participants offer services which are also listed in the service registry. And so, as I said, a participant could be, or is usually, it's a company offering some kind of a software platform. So these software systems can have a multitude of different users, as you have it usually with farm management systems. They offer a web-based interface, and you can sign in, and then you have access to the functionality. So these participants offer services, and these services can be accessed by via service clients. And to know how to implement such service clients, these services need to follow a defined standard, and this is the standard we define in Atlas. We call these, so to say, standards service templates. So services implement always a specific service template, and a service template describes semantically related agricultural or technical functions. So you have, for example, service templates for fertilizing or service templates for irrigation. And then you can implement services as a participant offering such solutions along such a service template. And once you have that service implemented, you can then put it in the registry, and then other participants can connect to your service by implementing a service client. And as it's standardized, they know how to implement that service client. And then once everything is there, you just have to pair services and service client to establish data exchange on behalf of the user. All can be seen here in the illustration. So the example shows here FMIS machinery platform and the registry, and the workflow which is used to establish that data exchange on a basic level. What we are doing on a technological side here is we rely quite heavily on REST APIs and OAuth 2 authentication flows. Yeah, as I said, participants are providing software systems offering services. Services are the basic interoperability building blocks in Atlas. Services are provided by participants, and services implement a specific service template. Yeah, I also said that participants are identified legal entities referenced in the Atlas registry. So if you are a participant wanting to join the Atlas interoperability network, you have to register for that. Then you are somehow validated that you are a legal entity. And then once that validation is complete and you are approved, then you are eligible to enter the service registry and to be listed there. So what we then have is a service mesh network. Each participant stays autonomous here. So the only requirement is that you are registered in the registry, that you are a legal entity, and that you implement services according to the standards. But besides that, you are completely responsible for implementing and providing these services. And the central components are, as we said, kept to a minimum. We only have, in the case of the data platform based data exchange, you only have the service registry as one central component. I mean, these are some details how participants are defined. Looking at the time, maybe we can also skip that slide and show it later on. And I would say more details could be provided upon request. So that was the short presentation.
Thank you, Stefan. I hope that our participants will have questions today. We have somehow a quiet audience today. I don't see any questions yet, but I have one. Stefan, could you probably comment on the topics we have this year? and especially the new one, and some requirements that we expect, what kind of technologies we expect that participants use, an overview.
I mean, the topics we have, let me just read the questions. The topics we have are listed on the website. So we have.
That was my questions. That was my question from me.
Yeah. Okay. So we have five topics for the open calls, around which we expect participants to provide solution for. We have weed and pest control as the first challenge. We call it not topics, we call it challenge. So we are expecting solutions, innovative solutions around weed and pest control related to precision farming tasks. So the goal here is to have a system which provides some really targeted application of pesticides to reduce the amount of pesticides or herbicides used in operation. This also includes early warning and risk assessment systems, and also alternatives for pesticides or herbicides, for example, using lasers for weeding or steam or these kind of technologies. Yeah, and what we expect is a eco-friendly method for assessing and controlling weed and pest infestations on farms. Yeah, the proposed solution should make use of at least one of the following technologies. It should use some kind of edge computing functionality. Robotic systems should be involved. Based on ROS would be a plus, or the use of in-field sensors is expected there. And then the second challenge is irrigation. What we expect there are solutions for irrigation management, irrigation optimization, to get control of the water usage, to only use that amount of water which is really required, which implies measurement and documentation of water usage, and also the development of innovative assessment and measurement systems to enable water saving. So we probably for this you need to know how much water is available, what is the soil water content, what is the groundwater content, how much water can you use, or how much water has to be used in order to prevent also overwatering. And what we expect there are irrigation solutions with optimized water usage compared to traditional solutions, climate smart solutions, software and hardware solutions are both welcome here, and it would be also or it would be required to use some kind of edge computing solutions, robotic solutions, and in-field sensors. One of these three would be good. Then topic number 3 is asset tracking and field management. So what we are expecting here are solutions to assess the quality and quantity of goods imported or exported from agricultural operations. Both hardware and software solutions are here welcome. So it's kind of a tracking solutions for agricultural equipment. So you need to know where your equipment is, where it is going, what is loaded, and where the things are brought to. So this could also include remote sensing technology and yeah, everything which is a practical approach. Yeah, also solutions aggregating and analyzing recorded data for documentation purposes are also in the scope of that. Everything which helps to reduce fuel consumption and to make documentation easier. Yeah, what we expect as an outcome is increased precision of these tasks, increased precision in the assessment of in and exported goods from a farm. One practical example here is nutrient flow balance on farms, so that you have solutions to document the amount of nitrogen, for example, going into the farm and leaving the farm. Also things or solutions which allow for a faster estimation of the transported material, of the material flows, and overall improved efficiency in fleet management, which then also leads to reduced fuel consumption and more efficiency by avoiding idle times, empty trips. So this is this challenge, and challenge number 4 is the called from farm to fork. So here we expect solutions which connect the producers, the farmers, to the food producers or other industrial players, or to administrative bodies and subsidy systems, yeah, to support documentation work, which all farmers are confronted with, and to increase the transparency and the exchange of data among supply chain members, to aggregate and integrate all forms of data, which sums up in these processes, and yeah, to enable also traceability of agricultural goods. And yeah, what we expect here is software solutions, easy to use, innovative, which make the life of the farmer here easier on the first hand, and which reduce the administrative workload for all supply chain members. And we also expect here a close cooperation with farmers for yeah, requirements assessment, and which or that the development of the solution is supported by end user assessment and end user requirements. And the last challenge we have in this round is related to livestock farming. Here we have behavioral analysis, livestock management, and environmental impact in the focus. So what we expect here is yeah, systems which use real-time sensor data to analyze the behavior of livestock. Everything which is developed here has to be also integrated into the interoperability network of Atlas. So all soft and hardware solutions need to have this. Also early warning systems for diseases or critical animal behavior are in the scope, and everything which helps farmers to monitor the livestock, to monitor the growth, the weight gain, and yeah, to predict also the future behavior of a herd, and to enable farmers to make informed decisions on feeding strategies, yeah, and medication strategies. And what is also in scope here is solutions which support the environmental reporting on livestock, operations. This is also related to the challenge of asset and fleet tracking. Nutrient balances are here the main area of focus. What we expect here is mainly software solutions or web-based services which address the problems mentioned, solutions which contribute to a reduction in the number of medications. Mainly antibiotics is here a really critical factor, and also solutions which contribute to improvements in animal health and animal well-being. The solutions should make use of edge computing technology, of robotics or in-barn sensors.
Great. Thank you very much, Stefan, for such a comprehensive overview of the topics. We have a question from Raja. If I understood correctly, the question is, Raja has a solution dealing with impact of irrigation on groundwater. And the question is if it's relevant to Atlas.
We need to see the proposal, but it would fit in the irrigation topic.
I think the important thing in all those solutions is to say the thing that's, it's important to agriculture, of course, but from an Atlas perspective, if you can, put your solution in the context of an interoperability scenario, because, if it stands on its own, it doesn't have that much value. Any solution that's proposed should, provide a sample usage scenario where you understand how the services you are offering could be consumed, integrated, and maybe assembled in a third-party solution. And as part of the delivery, have a very small proof of concept of such a thing. So if you can do that, then it makes sense.
Yeah, thanks, Mac, for pointing this out. So this is I would say crucial for all participants. So the solutions you provide should show a interoperability scenario. They should integrate into an agricultural workflow, because irrigation is not the only thing a farmer has to do, and everything you provide as a solution should make use of the Atlas interoperability network, and you should demonstrate a use case where you can show, okay, this is my solution integrates in this way into a whole agricultural process. And if you can do this, it's relevant.
Right. Perfect. I hope we answered the question. And just probably it's a silly question, but can you give an example of not suitable solution, of a solution that wouldn't suit to Atlas? Yeah, just example. I know you described in all ways possible what we are looking for and what we are not looking for, but probably just one or two simple examples.
One thing which is would not be really something we want is if you say forget about all the software you have, delete it and just use ours. So this is something we do not want. And also if it's if it just a solution is like, yeah, just download that app and then you have all the visualizations there, and yeah, and you can use it. So if there is no possibility to integrate that solution into other software systems, to import, export maps by the use of Atlas services, then it wouldn't be suitable for Atlas. So what you have to do is you have to demonstrate how you use an Atlas service to make data exchange possible. So if your solution does not foresee data exchange with other software systems, then it's not relevant for Atlas.
Exactly. So basically anything that's fully standalone that has its own user interface, its own processing, and it's kind of a black box, is not relevant to Atlas.
Okay, very good. Thank you very much. Yeah, I do see questions. Is there any provision for project oriented to soil, except irrigation, such fertilization, consultation, or soil analysis? In what challenge can we submit this kind of project? So that's more about consultation and analysis of soil.
Analysis would fit nicely, I would say. I mean, that's an area where we have some knowledge. I mean, it's always part of the process of determining eventually what are the nutrient requirements of a particular crop you're going to plant. It's very important to have a knowledge about the soil makeup and the natural nutrients that are there. And so, I mean, it's for you to think it out, but I would be happy to exchange with anyone who has ideas there. But it definitely fits into a larger scenario.
Yeah, so basically we can say to Panos has asked this question, so we can say that he can choose a challenge and describe and describe why it fits to this challenge, right?
Mm-hmm.
Okay, Panos, we hope that answers your question. Okay, he says okay. But yeah, if you have more specific questions, just drop us a line on the email. Another question, do we need to make an online web platform with visualization or just integrate within the Atlas network?
It depends what you want to achieve, I would say. I mean, integration in the Atlas network means that you implement a service, an Atlas conform service, which could be accessed by systems of other participants. And if your service offers visualizations for all kinds of things, then it for sure makes sense to offer these visualizations as a service. If you have an own platform for this, then we come again to the question of interoperability. Is it a scenario requiring interoperability between systems?
I would add to that somehow, though. I mean, there's nothing wrong with having visualization built in your application. I mean, that's not part of the service, really. It would be your own application that maybe uses its own service. But there should be also at least a sort of proof of concept, because very often you will not find another participant that has the time or the match to actually integrate your service. In this case, a minimal proof of concept about such a scenario. I mean, some sort of integration at the data level that can be extracted from your service that shows in a separate system, in a decoupled system, the same information that you could see in your visualization, maybe in a very raw format. It just needs to be a proof of concept if there isn't an existing participant willing to actually integrate with your server.
Okay.
I mean, that's what we do in different cases. For some use cases, Stefan's group has developed what he calls a test FMIS. It's neither going to be a product, but it serves to illustrate features of different services that are built by Fraunhofer. And so it definitely, as I said, because there's no one else, we don't have that many people who are just going to jump on the boat and say, oh yes, I'm going to integrate your service right away in time of the time of the open call context. So you need sometimes to do that extra step. As I said, a demonstrator that shows in the Atlas concept, so through the service registry, the formal APIs, that you have provided, an Atlas service. but you can still have your own UI.
Right. Thank you very much. So I hope that the answer is also clear. If not, Sugand has asked this question. Please just get back to us and say, like, I didn't understand what you were talking to about. So, and just we will specify. Right, I don't see any more questions. If you have any questions, you know where to find us, right? So the Atlas Open Call webpage and the Atlas project webpage is quite well known by now. You can just Google and see it, and all the information you can find there, including the answers to the most common questions. Again, we are very open. You can see that our experts, they find every week, they find time to answer your questions live. You can drop us any question you want to get answer on, and you will receive it as soon as possible. Right. So then, thank you very much to all of you, Matik, Malko, Stefan. Thank you that you found time to share your thoughts, your experience, your expertise about Atlas. That's most valuable for our audience, I'm sure. And thank you very much. We are looking for your proposals. I'm referring to the audience right now. And yeah, please apply for our open call and yeah, we will work together. Thank you, and we will see each other next week.
Thank you very much. Goodbye.
Thank you.
Thank you. Bye.